Hi and Assalamualaikum. My name is Nur Ain Shazwani binti Muhammad Shaizul, and today I would like to talk about drying curve. What is drying curve? Drying curve is a drying curve represents the drying process of a material and is typically plotted with moisture content on the y-axis and drying time on the x-axis. It illustrates how moisture is removed from the material over time under specific drying conditions. At the beginning of drying process, there is often a short period where the material temperature adjusts to the drying environment. This phase is usually brief and may not be distinctly visible on the drying curve. Next, we have the constant rate period. During this phase, the rate of moisture removal is relatively constant. The surface of the material is typically saturated with moisture, and the evaporation rate is controlled by the external conditions such as temperature, humidity, and airflow. The curve shows a linear decrease in moisture content during this period. Next is the first falling rate period. As drying progresses, the surface moisture begins to diminish and the drying rate starts to decline. The drying rate now becomes dependent on the diffusion of moisture from the interior of the material to the surface. The curve shows a nonlinear decrease in moisture content. Next is second falling rate period. In this phase, moisture removal becomes even slower as the material dries out further. The remaining moisture is bound within the material structure and is harder to remove. The curve flattens out, indicating a very slow reduction in moisture content. Next, we move to EMC. EMC in the context of a drying curve stands for equilibrium moisture content. The equilibrium moisture content is the point at which the material being dried can no longer lose the moisturizer to the surrounding environment because it has reached a balance with the ambient condition of temperature and humidity. This is the final stage in the drying process, where the moisture content of the material remains constant. Next, we will move to the importance of drying curves. First is for process optimization. Help in optimizing drying parameters such as temperature, airflow, and drying time for efficient moisture removal. And it for product quality to ensure that the material is dried uniformly and to the desired moisture content so we can preventing issues like over drying or under drying. Next, we will move to the application of drying curve in food industry. First, in drying of fruit and vegetable. It can help the optimization of drying condition, which can ensure that fruits and vegetables are dried to the desired moisture content to preserve nutritional value and extend shelf life. For the quality control, it can monitor the drying process to prevent over-drying, which can lead to texture and flavor loss, or under-drying, which can cause any spoilage. Next is drying of grain and cereals. For storage stability, ensuring the grains and cereal are dried to the appropriate moisture content to prevent the mold growth and mycotoxin production. And for energy efficiency, we can optimizing the drying process to reduce energy consumption while maintaining the product quality.